So this is the last lesson from Chapter 18. This is lesson 5, and we're going to look at integration by parts for a second time. But we're going to look at some slightly more complicated questions. So we're going to start by looking at, actually not that question, but this question. E to the 4x sine x dx. Now, there's no ln of x, so we know that this should be a perfectly regular question. We can call this one u, we can call this one dv. Just making sure, of course, that we can differentiate this, but also importantly, we can integrate this one as well, because if we can't do that, then we can't use that question. The other clue that we use integration by parts for this is like a product here we've got, and we can see the integration symbol. So once we've done that, and we've done our two separate parts, we can go ahead and we can use the formula. So really you should write the formula down here. So this is supposed to be uv minus the integral of v du. So all I did was I went ahead and substituted in at this stage. Now, as my integral up here has the e term first, I'm going to switch this around. Also I can see I've got two negatives here, so I'm going to make that a plus. And also any constants I can bring to the front of the integral as well. So I can say this is plus 4 times the integral of e to the 4x cosine x. Now to integrate this, clearly it's very similar to this one here. I'm also going to need to do integration by parts again. And that was really the reason why I wanted to rearrange these using the commutative rule. That I want to keep u as the exponential term, and I want to keep the dv as the trig term. So once again we can go ahead and differentiate this one, and also go ahead and integrate this one. Now I've got to be a little careful on this one, so I notice that this is part of my answer, and then I've got to do 4 times, basically integration by parts for a second time. So this time I did make it very clear what I'd done here, 4 times this. Just make sure you're substituting in the correct u and the correct v, because now we've got 2 different questions we're doing for this. And once again, I want to switch this around. I really want my e to the x at the start, and any constants I can bring to the front. And also, I can distribute this 4 now as well. So 4 times e to the x sine x is 4e to the x sine x. 4 times by this 4, and the negatives gives me negative 16. Switch this around, commutative rule again, e to the 4x sine x. And it looks like I've got to do integration parts by parts again, because I don't actually know what this integral is. Remember, this was actually the original question, so actually I've done 2 integration by parts, and I still don't know what the integral of e to the 4x sine x is. So it looks like I haven't actually made any progress in this question at all. However, there's a very clever step we can do now. As we know that the integral of this is this, although we can't solve this integral, notice these are like terms. The integral of e to the 4x sine x, and on this side I've got negative 16 e to the 4x sine x. So if I was to bring that to the other side and combine it, I would actually have 17 times the integral of e to the 4x sine x. And now I can actually solve for the integral of e to the 4x sine x. So if I divide both sides by, if I divide both sides by 17, then I do end up with an expression for the integral that I require. So for this question, this is one I think you should make a note of. Put a star next to it in your notes perhaps to draw your attention to this. Any question where you have e raised to some power and then either sine x or cosine x after, you're going to be doing this method. You're going to do integration by parts twice. You're going to end up with the same integral that you started with, but you should be able to combine terms and therefore be able to simplify. Of course, it could be 2e to the 4x, it could be 2e to the 3x, 5e to the 3x, it could be sine 2x, but essentially the method is going to be very similar for that. Now, if we look at a slightly easier question, it could just be something like e to the x cosine x. So I'm going to call u e to the x again. I'm going to do my integral for cosine x. I'm going to substitute into my formula again, so u v minus the integral of v du. I want to switch these 2 terms around again because I want to try and keep my u as the exponential function. We don't know what the integral of e to the x sine x is, so we're going to do integration by parts for a second time, and you can see that I've started to set this up. So for this integral here, I'm going to use integration by parts, which is this. And then I'm going to substitute in what I found for my u and v up there. Now this one we've got to be slightly careful on though, because there is one problem where people do make mistakes. When I simplify this, the 2 negatives are going to make this into a plus, This integral here, I've got the negative of a negative of a negative. Now I can bring the negative to the front here and combine this to make it a positive, but when I distribute this negative, the three negatives together are actually going to give me a negative. Now I've written out again what the original question was, because notice now what we're trying to work out the integral of is exactly what we started with. So I can use the same trick that I used in the last question. I can bring the integral to the other side and combine it as a like term. So instead of subtracting 1 times this integral, I can add 1 times that integral, giving me 2 times that integral, and then solve for that integral. So in other words, I'm just going to divide by 2. As I've actually gone ahead and got the answer for this, I can also put plus c on the end of the question as well. And I think I should have done that in the first question. I'm not sure if I actually did or not.